I'm not a doctor, but I am super excited to be here. As I said earlier, I'm an engineer by trade. So today I wanted to cover three things on AI, mostly related to software. But I think whatever I talk here are going to be relevant because I think many of you, whether you are a doctor or an academician, or if you are building software for doctors, whatever we talk here, I think is going to be relevant. So three things that I want to cover today. The first part is the mastering intelligence. This is about how we are embarking on the journey of solving intelligence. Second one is the acceleration of progress. I think in the last couple of years, we have seen dramatic increase in the acceleration. The third one is what it means, how this ascendance of intelligence will lead to intelligence as a service, which will be the new form of software that we'll be using. So the first section, so I briefly touched on this. So at Google, we are kind of, hit on our head to think about 10x thinking. 10x thinking is about how do you think about radical solutions for problems that are really big, and you kind of start unconstrained. Unconstrained is a keyword there because we are, as humans, tend to think everything constrained in our heads. So how do we think unconstrained and then come up with really interesting problems that lead to 10x improvement? So we have this formula in our company where there is a huge problem that exists, and there is a breakthrough technology that we can build, and a radical solution that we can bring to market. And when you put them together, you kind of see a moonshot. So the very original moonshot was Larry had this idea that we can index entire internet. Similarly, the other moonshots are like you can map the whole planet and make Google Maps, and now things like Waymo. So what is the next moonshot that we are working on? Our next moonshot is really about creating intelligence. So all the pieces in the world that you experience today, whether it is like these buildings or the better healthcare or the cars and the cities, all of these things are product of human intelligence. So our brains, as humans, we have used them to create the world that we live in. So the question that we ask is it possible to create intelligence on silicon? Not just on organic matter, but can you create that on silicon? And when I talk about intelligence, I'm not talking about the traditional machine learning models that we have built custom, right? Like, if you need a vision model, we built that. If you need a language model, we built that. So those are all custom-built, task-specific models. What I'm talking here is a general purpose intelligence. General purpose intelligence is like our brain. When you're born, you have basically no skills, but then you kind of watch the environment and observe and experiment and learn. And if you look at the entire process of how humans evolve and how their intelligence evolves, there is a method that comes very close to both mathematically and in computer science, which I'll talk about, that is what we are trying to replicate on machines. And to a bit of a background, it goes back to in 2012, 2011, we had a paper that talked about how you can bring deep reinforcement learning as a technique to teach machines, or machines can self-teach themselves playing games. And I'm assuming some of you have seen it. The video won't play here, but essentially this is about a machine playing an Atari game. But this machine had no input other than the pictures of the screen that it is playing with and the score that it is making. So there are no rules given. There are no pre-training was done. All it can do is like observe the screen and understand the score. And by bringing two mathematical models together, one is on the deep learning side, which is how can you bring the Q value or the value function as a neural nets. And the second one is reinforcement learning as a mathematical concept. How do you teach the machines to learn about the environment and then behave certain understand the policies and behave certain way to accomplish the tasks? So that was a breakthrough. So from that breakthrough, we kind of advanced our reinforcement learning and deep learning in different ways. AlphaFold is one of those breakthroughs. AlphaFold is solving this 50-year-old grand challenge in biology, where we have no idea in the past how our proteins, there are about 200 proteins, proteins in our body, and there is no way that you could actually each cell and each protein, how they fold, which is the amino acids that actually form these three-dimensional structures. And once you understand it, it can actually create new ways of discovering drugs and treating diseases and so on and so forth. The 60-year-old grand challenge was again solved with deep learning and reinforcement learning with our DeepMind techniques. Now, it's not just the AlphaFold. We also have multiple layers of intelligence that we have built. One of them is AlphaCode. AlphaCode is literally an expert level programmer. So it can code and write programs at an expert engineer level. GraphCast is another breakthrough from AI that predicts weather more accurate than any other weather prediction model that ever existed on the planet. And now we are working on plasma control. Plasma control is an interesting problem. If you are thinking of building portable nuclear reactors, you want to be able to control plasma in a way that it actually is self-contained within a container. And obviously, because of the high temperatures, you cannot really build a material that can control plasma. So we are simulating, using AI, we are simulating the plasma shape and the controllability using the tokamak reactors and the magnetic forces. Again, if this works out, you can imagine a future where every one of us will have a mini nuclear reactor in our home, powering our entire house forever for free.